Now let's talk about what are the best practices for designing the classes. So the first rule of classes is that they should be small. Now here you can ask how is small? So we decide that by counting the responsibilities it should hold. And here comes the idea of single responsibility principle that says that a class or module should have one and only one reason to change. This principle gives us both a definition of responsibility and a guideline for the class size. So, ideally, the classes should have one responsibility and only one reason to change. We want our system to be composed of many small classes, not a few large ones. Each small class encapsulates a single responsibility, has a single reason to change, and collaborates with a few others to achieve the desired system behaviors. The second best practice that we need to follow is that cohesion. We generally prefer the high cohesion. So, what is cohesion? Cohesion is the degree to which the element inside a class belongs together. It's about the relationship between the data and the code inside a class. If the method that serve a class tend to be similar in many aspects, then the class is said to have high cohesion. So for the high cohesion, the class should have a small number of instance variable. Each methods of the class should manipulate one or more of those variables. The more variables a method manipulates, the more cohesive that method is to its class. So why the high cohesion is preferable? Because when cohesion is high, it means that the methods and variables of the class are code-dependent and hang together as a logical whole. In simple word, that means a module with high cohesion contains elements that are tightly related to each other and are united in their purpose. And if your module, your class have unrelated elements, then that is called low cohesion. So, in a nutshell, cohesion says the code that changes together is stay together. But at the same time, maintaining cohesion results in many small classes. And that's a different topic of discussion, which we'll do all in the later part. Now, the third best practice for the classes, as suggested by Robert C. Martin, is you must organize your classes for change. As we know that for most of the systems, change is essential and continual. So, in a clean system, we organize our classes so as to reduce the risk of change. We want to structure our system so that we mess up with as little as possible when we update them with newer changed features. And as we know, in an ideal system, we incorporate new features by extending the system, not by making the change into the system, by making the change to the existing code. So when we organize our classes for change, we need to isolate them from change too. And as we know, there are concrete classes which contain the implementation, the code, and there are abstract classes which represent only the concepts. So, a client class, depending upon concrete, is at the risk when those details change. And there we introduce the idea of interfaces and abstract classes to help isolate the impact of those details, which we'll discuss in the next part. So, these are just a few points that one should keep in mind while crafting the classes and organizing their data. If the intent is to design a system which is clean and which will give you less pain in the future.